In coordinate geometry, what we say that a line passes through a point x1, y1, and it has a gradient, which means it has a particular relationship to the x-axis, whether it is rising or falling as the x-axis is increasing. So that is the gradient. It's a ratio. So we say that the equation of the line is y minus y1 equals to m x minus x1. Now in coordinate geometry, this particular equation, also known as the Cartesian equation, it is a two variable equation. It has a relationship between x and y, which can represent this line in a pictorial format. That means we see what the line is graphically. So this completely represents this line. However, when we talk about the vector equation of a line, we say that there is a point and it passes through the point. If we say x1, y1, if we talk about only two coordinates and it is parallel to this, so let me call this direction vector. So in that case, we write that the vector equation is position vector of the point through which the line passes, so which is x1i plus y1j plus lambda. Lambda means compared to this parallel line, compared to this direction, how far away is a universal point. So that is lambda of the direction vector. Whether it is a parallel line or whether it is collinear, it does not matter. So the equation that we have over here, known as the vector equation of the line, is actually not the equation of this line. It is not representing this line. It is not at all. So it would be misleading. It would be a false conception to think, just like we write y minus y1 equals to mx minus x1 in coordinate geometry, and it is representing exactly this line in graphical representation. But when we write the vector equation of a line, it is not representing this line at all. What is basically being done is it is representing the position vector. If this universal point is x, it is basically representing the position vector ox. So this thing is actually the position vector of any arbitrary point which is lambda scalar away from the point through which it passes. So that's what it means. So there is a distinct difference between the equation of a line represented in coordinate geometry and the vector equation of a line. So it would be better to think of this like, if you have a line that passes through the point A, B, so the direction vector is AB, and this is the starting point A, then think of this as a point far ahead, a universal point. So if this is AB, then AX is going to be lambda of AX, lambda of AB. So AX is going to be lambda of AB because it is in the same line, so it has a scalar relationship with AB. So this is AX. So what we want to know is basically what is this OX, the universal position vector, and it would be a different value of lambda will give a different point. Every value of lambda will give a different point because its location on the line will be different. So in that case, what we can do, if we can think of OA and then we can think of AX. So by this clockwise anti-clockwise rule, we can write AX and OA. If we add them together, that will be equals to OX. So therefore, we can write OX is equals to position vector of the first point plus lambda AB, because AX is basically far ahead, a location far ahead of AB, but in the same direction. So it is lambda direction vector, and that is the idea. Every time we are talking about the vector equation of a line, we are not talking about the equation of this line that is represented usually. We are actually talking about the position vector of a universal point on that line, which depends on the value of lambda. So different lambda will different exactly different points. So for example, if we have a value of lambda, suppose this is the first value of lambda, let me call this lambda 1. So maybe in that case, for lambda 1 the point is over here. Let me call this point P. Now, if you have another value of lambda, let me call this value of lambda as lambda 2, then we'll have another point, uh, point q. So that's how it is done. So a different value of lambda will represent a different point. So similarly, a single point will have the specific value of lambda. For that point, it cannot have any other value of the constant other than a specific value.